Okay. Howdy, y'all. Oh, God. I left myself volumed. The worst thing in the world is when you start a stream and you have your stream tab open to make sure it's working and you left the volume unmuted and then you hear yourself and you're like, oh, God, why does anyone watch me? All right, so welcome. Today we are going to get back on the RDP grind. Since last time, if you'll recall, I was trying to get an RDP list to work with, so I spent a lot of time messing around with whatchamacallit, uh, with Mupen. And so since then, what I did is I got N64 running instead, dumping the RDP stuff, and I got it to actually run Crom's test ROMs so that we would have better testing stuff to work with. So let's just go ahead and run that, huh? It's probably going to be in build, because I did run this just to grab. Right, so if you check this out, rdplist.bin, it's a much smaller amount. It's nice and short to work with, and so we're just going to work with that. And if we go ahead and all right, so the first thing that we're going to want to do is we're going to want to print out all of these RDP commands, display list commands, so that we can get started on working on it and see which ones we need to actually implement. So let's go ahead and do that. I don't know why I can't type today. It's been a minute since I streamed. So I'm a little bit feeling off my game slightly. Okay, so for starters, these are little Indian. Except they're little Indian U32s, which is not really all that correct. Let's just go ahead and fix that, shall we? Whew. Hi, Lila. How you doing? So what I'm doing here is because the way that these commands are set up in N64 is as U32s instead of U64s. We're just having to do a little massaging to get them to come out correctly. Rewriting my raster function for my C64 VIC2. That's very cool. I have been watching your progress in the Discord. Seems like it's going pretty good. Yeah. Give me another terminal here. Can never have too many terminals open. Oh yeah, of course. I always forget. N64, you need the PIF ROM. Yeah, only thing is I need to be more precise in timing. Oh, yeah, okay. All right, so as you can see, we've got N64 running. It's displaying these triangles. This is ultimately what we're going to try to draw as our starting point. And you can see down here that we logged 122 words. And hopefully, we XXD on the RDP list. No, that seems to have made it worse. So what we're trying to get, if we look at the source for this here triangle test, which is this one, the very first command is going to be set scissor, I guess. And if we look at our RDP commands PDF, which is right here, and we look at set scissor, which is on page 36, it's supposed to start with 2D, and it does. It's just that it's on the wrong side, basically. Those are Crom's tests. Yes, correct. What? Okay, there we go. That is the same, which is odd. I thought I was byte swapping you previously. Yeah. So, is there a better way to do this? I guess LE32 H2BE32. Let's try that one. Even though that really ought to be the same thing. What the heck? Oh, I am so dumb today. Holy cow. That's incredible. Alright. Well, it turns out if you don't rebuild, nothing changes. How long has it been since I did this? Not long enough to justify that. Alright, well. Look at all these warnings. What's your problem? Implicit function declaration. Gotta include ARPA inet.h. Let's go ahead and do that. Okay, tons of warnings, but no errors, so that's good. That's what we want. There we go. That ought to be better. XXD. Oops. Whoa. Somehow this is a lot longer now. That doesn't seem right. Oh, turns out I wrote it out twice, so okay. And let's see. Still seems way too long. But at least it's in the right order. Or appears to be. Let's compare against RDP commands again. So we get 2D. And then 108A in this section, which is XL and YL. Does that match here? I mean, yeah, it seems reasonable. Okay, so that's good. Progress. And then what's the next command is set other modes, which hopefully starts with 06. Where are you? Set other modes. Page 27. Nope. Command 2F. Cool. So what's this extra crap then? Oh yeah, the faint emoticon is a thing that exists now. Oh, I'm writing way too long, that's why. Hooray for cat emoticons. Who dis? That is my cat faint. I am Andrew. I'm working on an RDP renderer. Gonna render this test. That's the plan. You probably know that already. Alright, that looks way better. 2F30. Awesome. Okay, cool. What does set scissor do? It sets the scissor. "13 more subs than meat joins." Yes, that is true. Thank you for pimping my channel. Yeah, it sets the clipping coordinates. I was just kidding. It basically says like we're only gonna render stuff between these coordinates, otherwise we're gonna throw it out. Okay, so here we are. We got commands. We happy. So do we actually care about set scissor right this second? Probably not. What other commands are in this list? So we got set scissor, set fill, which again we're just going to assume, set color image, just sets like the pixel format, I guess, and then the address. So we probably don't need that for now. Fill color, we definitely need those, so let's do that. And then don't care about fill rectangle so much right now. Just ignore that. Don't care about this because it just turns everything off. Same. Blend color, that's probably important. I don't really know. But we'll ignore it for now. We'll just do the fill color. I'll need the color location. I'll only need the color location if I'm actually going to like render to a specific address, but all I'm going to do for this right now is just dump it to a frame buffer and draw it on the screen. Eventually we'll need all these things, but not right now. Okay, so we're just going to do... it looks like we are changing the blend color. So maybe I need that. Anyway, whatever. Let's start with set fill color. Set fill color, and then we're gonna give out whatever that does. Set fill color is gonna be color 34. Fill mode doesn't use the blend color anyway. That's interesting. I wonder why Crom is changing the blend color then. Because he doesn't change the regular color. He only changes the blend color to draw the different colors of triangles. All right, so we're gonna want to set a color format. It's a packed color. It's either going to be 16 RGBA or it'll be right. It's a cycle 1 test. Yes. Oh, sorry about that. That's a little overzealousness on the part of Nightbot. Let me turn that up. Hopefully it won't be too much of a problem. Where is the thing that tells you how fast that happens? No, that's not it. Blockless words and phrases, links, symbols, repetitions is off. Huh, okay. I can't figure out how to change that, and I'm not going to spend a ton of minutes. Oh, posting caps. Okay, so that's what happened. Let's just turn that off. Whatever. All right, there we go. Cycle 1 mode needs a bit of work to get going. Is this Magic the Gathering? No, I was playing that earlier. I stopped now. Oh, so you're saying I should use the non-Cycle 1 test? I didn't honestly know the difference. It seemed like Cycle 1 would be easier than Cycle 2, but if that's not the case, we can always do it the other way. Scissor, color. Oh yeah, so this is setting set fill color. All right. Yeah, let's just do that then. Doo-doo-doo. Go, okay. Fill mode just rasterizes and outputs the fill color. Cycle 1 goes through the entire pipeline. All right. Makes sense to me. So let's just go ahead and run that instead. I assumed it was in contrast to 2 cycles, not as in contrast to like something easier. Oh, hey, would you look at that? They're like all whiny and weird. I wonder if that's a rendering artifact. I guess not. Let's see what it looks like in the picture that is included with the test, because Crom is a gentleman and a scholar. Oh no, they're all whiny and weird, so okay. Alright. Works for me. Go ahead and kill that. It's because the fill color is split into 2 pixels. That makes sense to me, more or less. Maybe I should use the non-16-bit version, actually. That seems like it'll be easier. Let's do the 32-bit one, huh? Fill triangle, non-cycle 1. All right, be the easiest one. Okay, yeah, that looks more like I was expecting. Probably be easier to parse anyway, so let's go ahead and do that. And since this is obviously modal, we're gonna do we'll just call it fill color for now. Maybe it will turn out to be more than just fill later, but just going to represent it by two U32s for now. If it's 0x37, then we know that it is set fill color, and so what we're going to do is to handle both color modes. For now, assume 32 BTP. Alright, and so since it's not, it's going to just be packed straight across, right? So set fill color, these are the wrong sources. There we go. Alright, fill color is just straight across RGBA. Alright, cool. RDP command fill color, and it's gonna be, oops, oh, there's no comma there, just comma there, and then color 1 is just gonna be value as U32, so that'll clip off, and then we'll just do the same thing here. Oh, I didn't derive debug for it. Sup? Hi Phantasma, how you doing? Magic doesn't seem to be nearly as impressive as the British Enigma decryption efforts. That is true. However, Ultra was already taken by Nintendo because they're big jerks. The fill color is 32 bits regardless. Yeah, I know, but it's 2 packed pixels, right, for 16-bit stuff. And I'm just going to expand it out into 32-bit because I'll just do all my rendering with 32-bit, unless that's dumb for some reason. Also, the Polish people always forget the Bomba. Not me, man. Polish cryptographers, where it's at, World War II, for my money. Alright, so that looks basically correct. Let's start at the top, make sure we got it all matching. FF. Oh, it doesn't actually look like it is matching, is it? Alright, well, let's fix that. Go ahead and dump that and see what we get. FF01, FF01. Am I still running the old thing? Yep. Guess who didn't copy the thing over? Dumb. Alright, there we go. That's better. Okay. I didn't think I could have possibly screwed up something so simple, but, you know. Alright, there we go. So now we're parsing fill color. The next command that is of interest to us is going to be the actual fill triangle command. So let's parse that. RDP commands. Fill triangle, where are you? There's fill rectangle. Fill triangle is probably actually edge coefficients, right? So unknown command 36, 27, fill color, and then it's 88, which we just clip off the top bits, I guess, for whatever reason. That is very strange that like the RDP commands sometimes just have extra bits set. Anybody know if there's a reason for that? So hopefully that was F that I implemented before, which is the most complicated one. I don't know why I did that. It's obviously wrong. It's not F, it's 8. Maybe that was all I had in the old one. Do. Code. Come to Bletchley Park. I would love to come to Bletchley Park. That sounds really cool. I'm confused. How is that not matching? It's 8. It really should have gone into here. That's very strange, huh? Okay, so it says got edge command, but then it's just like not returning. Okay. That's weird. Oh, maybe this is why. Yep, that's gotta be it. Yeah, I probably overdid this. So if we do look at this, we get 1, 2, 3, 4. So this probably actually is an F command here. And then we'll get rid of these, and then we'll just only do the top bit for B, or for 8 rather. And then we'll just return it with all the rest of this crap set to 0, I guess. That's maybe a dumb thing to do, but yeah, that's not right. You're right, it's not. No, I had it right the first time. So how come I end up with no more data? What kind of result do I get? I need this to remain as 8. Unexpected EOF failed to fill the whole buffer. That doesn't make sense. Because there is, in fact, plenty of room left in the buffer. You can tell on account of it fills itself again later. So I do that, will it just die? Nobody will get anything? That's so weird, huh? Okay, I have something wrong here, obviously, in terms of how I'm dealing with this. Let's look at the documentation for IO read. see what dumb thing I'm doing here. Each call to read will attempt to pull bytes from this source from the provided buffer. Yeah, sure, obviously. What if I just make it read 4 or 8 instead? Will that still explode? Oh, it needs a place to put it. Okay, fair. Huh. Apparently it's fine to read 8 more bytes. But illegal to read 64 8 more bytes. That's very odd. Oh, it might just be returning less than. Yeah, so if n is 0, it won't actually die, it'll just be 0. Yep. Oh. Okay, I get what's going on. Once again, just being silly. Okay, so here's the problem. The problem is that we're doing this weird swirl here instead of just using command. Which that's probably not right either, is it? Because I implemented this for IO read, which is implemented on byte slices. So what I actually want to do is instead of read 64 into and doing it this way. Yeah, so this is all just the leftover from when I was trying to do into instead of read. So let's just fix that. Okay, and then we're just going to do read into, none of the U64 junk. Command bytes, and then what we actually want to do is while let just do while true, I guess. Then it'll die. No method read into. FS file. I mean, it implements read. Does read not have a read into? I guess read is read into, huh? It's dumb. Oop. No method named read. You have to use standard IO read. Okay, fair. Right, and then can't find value commands. Geez, so much junk here. Right, so that just needs an S. And then I think you need to borrow this or something to get it to be a slice of U8s. Except it's probably a borrow mute. Oh, okay, I know what I'm doing wrong. I need to slice it. So let command slice equal command bytes dot dot. Command slice. Num bytes not found in this scope. Num commands to num bytes g. Go. Cannot borrow is mutable, which is fair. Okay, now it's just dying forever. Whoa, ah, cat. Hello, Jesus. That's the face sake of the emote. He's cute and fluffy and very annoying sometimes. He's a good boy, mostly. Sharp claws. Who takes care of you? Don't they ever cut your nails? Goofus. All right. Yes, indeed. So I think probably we want to do a while let here. Except that won't really work either because it'll give us the wrong thing. If let, well, obviously it will be. Commands dot, I forget how result works. How do I get the error? It's like unwrap error, I think, actually. Oh, this is the module I want to type. Yeah, just an unwrap error. Yeah, that's obviously not going to work, so we need to use standard IO error kind. This is one of the best things about Rust, by the way, is that I can just like try to run that, and it'll be like, hey, by the way, this is the thing that you're missing. Like, oh, thanks. Value borrowed here after move. Okay, there we go. All right, we parsed some stuff. That's good. Now we don't have all these problems. Let's get rid of all these print lines. And now, happy days. Okay. Pretty sure this is wrong, because all of these need to S value data G. What are all these warnings I'm getting? Are they unnecessary extra parentheses? Yeah. Thanks, friendo. let's just do that. I made the switch to N64. Yes, I did. How's it going? Thanks for stopping by. Oops. Oh no, that was right. And then the other thing is just to get rid of this. Okay, now hopefully we don't have all those. Got a few unused imports, but I think that's probably fine. Don't use an infinite loop. Fair. Alright, let's just get rid of those, and then we'll just do loop. Is N64 documented well? Kinda. It's documented pretty well, but it's a little bit all over the place. And some of the documentation has problems, and it's not necessarily well documented. Which documentation has problems? Whoa. But by and large, like, most of the information is out there, and for what isn't, I bought an EverDrive so that I could run actual hardware tests. Also, the tests that I'm using, which are from Crom, who is Peter Lemon on GitHub, they all were tested on a real N64 as well. So there's information available if you're willing to go and look for it a little bit. Alright, so now let's just confirm that our first fill triangle command actually matches what we're expecting here, and we get, so right major is true, I guess, direction 0, let me just double check that that's what that does. Left major is 0, right major is 1, so that doesn't seem right. I have to double check that. And then level 0, tile 0, YL, this says 100. YM 50. None of these really seem correct. Well, maybe they are. I don't know, hard to say. Where's my... Maybe if you're really cool, you can do hex in your head, but I always have to do this. Okay, so that matches actually. And then the C8s are 200s. Okay, so that's correct. It just has to do with how the conversion goes that is confusing. All right, and then 4B is 75, which is this part, apparently. Does that match? I mean, it's hard to know without knowing what these arguments are supposed to be, but at least it matches something. X fraction of 0. Yep, the other 75. 0. XH at 19, is that 25 over here? 0. dx dy is, or dh dy is apparently also 25. That doesn't seem quite right. But it doesn't seem like this gives enough data, actually. So those are those bits, presumably. And then there's 3, 4, 4, 4. Look at the command. Got 3, 4, 4, 4. Okay, so it does match. We just parsed it wrong, apparently, because we should end up with all the DD whatevers should probably be 0. Is that right? I should look at the macro that this is calling, which is going to be in the support stuff. Oh, am I looking at the wrong fucking file? I gotta close all these other files that are not the right file. Goodbye, goodbye, goodbye. There we go. But I still need to do the thing I said I was going to do, which is look at the lib. It's probably in graphics. Fill triangle. Level flag, left major, level, tile, Y, M, H, X, LF, DXY, DXY. Okay. So let's just compare these. All right, we're going to take that, go over here, going to take this one, shrink it also, move it up so we can see them both, and then compare against here. Okay, so fill a rectangle or triangle. 0, 0, 0, 0. Obviously, we already know right major is wrong. Level is right, tile is right, and then we get YL, YM, YH, which we checked, and those are correct. Then we have XL. So that's supposed to be 25, but it's not. 0, 0, 0. Okay, so why is that wrong? Obviously, I'm just parsing it wrong. It's not like a big mystery. Let's take a look at, so this, I think, just matches straight across, right? XL, XLF, DXL, DLY. Yep. Yeah, okay. And so I have this as U16, which is obviously wrong. Or is it? No, it's not. It's right. Okay, so fraction, dx dy. Oh, because this is wrong. This needs to be not shifted. And this needs to be 20, no, not 24, 16. That's why. All right, that makes sense. Just another silly typo. Copy paste error. A classic. This is why we test. All right. Doodly-doo. Doo-doo. Let's try that again. Compare with the source file, which is this. All right, so now we've got XL is 4B, which is 25, I think. No, it's not. B is 75, so we're still doing this in the wrong order, apparently. Hi, Lofty. How's it going? For 1632, yeah, okay. What dumb thing am I doing now? Going pretty well, not sure how long I can stay. That's cool, I appreciate you stopping by. I know you're on Europe time, so. Okay, so how come my XL is ending up wrong? What if I look at the... Alright, so if we take a peek at the actual command, which I guess is this one, then we get 0190, yep, C8, C8. 4B. That does seem like it should be correct, but it doesn't match what's described here at all, which is annoying. Right? Because this is the next, well, okay, so from this one, this is the next set, and you get 4B00FFFF. Favorite language and why? I don't usually think about things that way, but I do have a pretty big soft spot for Ruby, even though I never get to write it anymore. And then obviously I like Rust because I'm using Rust for this project. This doesn't make any sense as a command set. 4B obviously comes from somewhere. 19 also obviously comes from somewhere. I guess -1 is FF, so that makes sense. But they're just like in the wrong order. Like this middle bit is showing up first. So I wonder if I'm doing the commands in the wrong order. What's command 37 again? Not too much. Ruby I like because it's very flexible, like you can kind of do whatever. Rust I like because it doesn't require a runtime, and I think that that is hugely valuable in a lot of domains that I often work in, like embedded. And it's also not as mostly terrible as the other options in that space are. Sounds like you need to write a disassembler. Yeah, I mean, you're not wrong. I'm sort of doing that, though. Like, it is printing. I just didn't want to do all of the commands in a row. I wanted to only do what was necessary. But maybe I should just go for it and do all of them. So, I've lost track of thought. Okay, so 37 is set fill color. And if we go through this set, I know the set says there's 2D, 2F, 3F, 37. Fill rectangle, it's got to be all this junk. I don't know how big that is as a command, but sync pipe, probably 27, 37. So this is correct, like they're in the right order, but then this seems to be in a backwards order, which is odd. When you look at the actual macro instead of just the documentation for the macro, because we all know how often that's wrong. This is not actually the definition at all, so I'm sort of confused. Am I looking at the wrong thing? Maybe it's in here or in the header. How's it going? Slowly. I'm kind of hung up on some fairly basic stuff right now. Specifically, trying to figure out why I'm getting data backwards from how I expect it, or like in a different order anyway. So if I take a look at this, this is the first little bit of the fill triangle command, but then this is not, or I'm looking at the wrong thing. This one is the second chunk, and then we like go back to the 25s or something. I don't know. It's a bit strange. Actually, it looks like you get 75, 25, 25, which is not right either. That is this one, actually. That's commented out. God damn it. Okay. Holy cow. Oh, man. That's... Wow. This is not my best day for detail work, I guess. The command I'm comparing against is not a real command. Awesome. Okay. True, 0, 0. 400, 200, 200. 75, 0. Negative 1, 0. 25, 0, 0, 0. 25, 0, 0, 0. Okay. Everything's fine. I was just looking at the wrong thing the whole time. Cool, 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 cool. All right. So now we have a display list command that is a fill triangle command. If we take a look at the documentation real quick, what this gives us is basically edge coefficients, which can be used to derive edge equations, and that's how you draw the triangle, as opposed to, like, I don't know, anything that would make some kind of sense. There's a pretty cool Glide N64 blog post which talks about how this all works. So basically, what you have is inverse slope for a major edge and two minor edges, and then these coordinates are not actually coordinates of a vertex, right? It's a little bit different than you would expect from a modern graphics pipeline. I don't know if you can read this, actually. I should zoom in. So basically, the RSP takes in a list of vertices, but then it chomps them up and spits out these edge functions, right? And so the way that you figure out whether you want to draw something or not is you basically check, like, what is in between the edges, and you draw the stuff that's in between the edges. So that's what we're going to try to do. But first, I got to run and fill that cup again. So give me a couple minutes. I'll be right back. And I'm back. Okay, cool. So, before we can start rendering, we need something to draw to. So that's our next step. And I already did most of the pre-work for this because nobody wants to watch me screw around trying to render stuff, as we proved during the N64, the NES stream, the very first one. So we're just going to grab all these things. We're going to be using Dear Ingui for rendering, and we're going to be using the WGPU backend, which is sort of the new hotness in Rust examples, or in Rust graphics rather. And it's a little bit rough around the edges still, I think, but I was able to get an example running. Failed to load source for a dependency on Ingui WGPU. Oh, it's because I need to back out one more for some reason. There we go. Go. Alright, so that's going to compile for a second, but basically it's just going to give me an Ingui window with a frame buffer. Thank you for the bit, Diana. You are now number 1. Challenging someone to defeat you, sort of implicitly. Alright, so this is going to just chew on itself for a minute. And then basically what we're going to do is currently this renders Lena, which is sort of a standard graphics test image, and it's just going to render our frame buffer instead. It just takes in a U8 of bytes, basically, which are an RGBA texture, or an RGBA pixel color, and then it just draws it. It's pretty straightforward. There's a lot of sort of extra boilerplatey stuff, which I could maybe hide away a little bit better, but we'll deal with that as we go, I think. Or actually, I'll probably deal with that between streams. I'm not forcing myself to do all of the work on stream for this project like I was for the NES, so I'm going to do a lot of the like regular-ass cleanup stuff off stream. Because I just don't think it's interesting, and I don't want to subject you all to that. There we go. Alright, so as you can see, got a beautiful window. It's got another beautiful window inside of it. Got a beautiful lady looking over her shoulders. And, yep. So this is our demo window. We're just going to replace this with our N64 viewport and then go to town. So let me first change the width and the height. So the frame buffer here gets set up when we load Lena. So we're not going to do that anymore. With capacity is going to be 320 times 480 times 4. We'll blow all this junk away, and we'll do, seems to be let mute, resize width, and we're just going to make everything FF, I think. Is that going to run? No, because they got rid of that other stuff. Oh, I probably deleted a little bit too much. It's interesting to see how people modify their Vim installations. I've seen everything from vanilla installs to full Monty IDEs. Yep, that is a thing. I 320. No, the other way around. Right? 480 U8, 320 U8. Am I a banana person? Oh, it's 320 by 240. Okay, that makes more sense. 320, 240. Okay. And then they're not going to be U8s, they're going to be U32s. But you should be able to figure that out. Raw data not found in this scope. Yes. FB data, or FB bytes, I think I called it. Should probably just call it FB. Lena text ID is gone. It's FB text ID. Oh yeah, it needs a size. 320 by 480 by 4. And that comes first. For what it's worth, I used a relatively minimal installation and then realized I could get most of what I wanted from Vim using Sublime Text with Vim key bindings. Alright, there we go. We drew a white square. If we go to 0, well, it won't work because we'll get a black square that's also transparent. It's not ideal, but yep, black square that's also transparent. So that worked, which is cool. So now we have a thing to draw on. And we're going to want to use magic. Yay, the frame buffer is here. Yes, indeed. And what we're going to do for this is we're going to take the frame buffer, which is in N U8. And we're going to take whatever I called this, struct edge coefficients, all right? Magic edge coefficients, and then we're just going to go ahead and draw it. All right, so that's unused. And then what we're going to want to do is every frame draw triangles. And we're going to call draw, fill, try. And we're going to pass in mute FB bytes, which I should probably do, should just FB. And then for now, magic. We don't actually have a good way to do that, do we? I don't have a default implementation, although I probably should. All right, so let's go ahead and just take that first triangle from our list up here. There we go. And literally, we can just go ahead and snag this whole thing. Get rid of this. Set paste. Boop. Set no paste. Set no paste. There we go. This is obviously garbage indentation. So let's fix that. And then hopefully this should run. Nope. Gotta use magic. Once again, Rust being super helpful. Just says like, hey, you probably wanted this. Like, yeah, okay, but thanks. Oh, everything's private, obviously. Well, let's just make all of these public for now. We'll fix this later. What plugins do I use? Let's look at my VimRC real quick. Not a lot. I don't use very much. So I have Bundle to manage stuff. I use Smart Tabs. I have a couple of syntax highlighting plugins, CMake, Puppet, YAML. I use Tabular. some color scheme stuff. Buddy is the one that I'm currently using, and that's about it. For a while there, I was using like a smart search and replace thing that could do a bunch of cool stuff, but then I didn't really do that. But everything else is just sort of configuration stuff. The main thing that I love is this. I remapped escape to JK very quickly because it's a no-op, right? So if you're just idly doing it, nothing happens. It's really convenient to not have to reach all the way up to escape all the time, and people always say use caps lock, but I don't like using my pinky to press things. The only downside is that if you go into paste mode, then it doesn't work. So sometimes when I'm trying to exit paste insert mode, it's like, this doesn't work. Okay, so that works without actually doing anything. And now what I want to do is for I in 0.fb.len. Am I running nvim or just regular vim8? Regular vim8. This is Cygwin actually under Windows, so I'm not sure they have NeoVim or nvim or any of the cool ones. Alright, so this should give us like a grayish color. Yep, grayish color. Hooray! Alright, just one more test and then I'll be done screwing around and start actually trying to draw something. If I mod 4 equals 0, alright, that should give us a pretty reddish color. Pinkish. Close enough. And then this should be bright, obnoxious red. And then I will be convinced that things are correct. Oh no! I switched to nvim last month and I think it's a lot better and also a lot faster than vim8. Maybe I'll take a look, see if it's available in Cygwin. Why? Why don't you work? Oh, I know what I did wrong. Dummy. Also has a lot more support. There we go. It turns out if you don't have the else, then you're just writing 0 to the alpha channel and you can't see anything. Hooray! Bright red Lena box. It's not anything to do with Lena anymore. Let me get rid of the Lena text. Alright, so now we got a place to draw to, which is great. And now we need to figure out how to actually draw. So let's take a look at that blog post I just had open. So basically what you do is that you're going to, these things make a line, and then you draw everything that is inside all of the lines for some value of inside. And what tells you whether it's inside or outside is that flag that says whether it's right major or left major. Which basically is like what order are these points provided to you in. This is probably going to be kind of a slowish process because I'm not actually very familiar with graphicsy stuff. I read like there's this series of blogs, which I think are great, this optimizing software occlusion culling set that talk a lot about like edge functions and whatnot. Like this is, that's what edge functions kind of look like. But I just have not done a lot of this, so it's hard to say how long it will take me to figure out the various things. All right. Inverse slope for major edge and 2 minor edges, which corresponds to you know, we should just print it out in here so I don't have to scroll up all the time. coefficients. There we go. So we can get rid of this, so we don't need it. Alright, probably don't need to print it every single frame, but whatever. Okay, so you have inverse slope for major edge and two minor edges, and that's the M values, I think. This is YM. Let's also open this in the next tab over so we can zoom in. Actually, that's not helpful at all. The one in the PDF is actually a relevant resolution. Where is this picture? I know it's in here somewhere. There it is. All right. Yeah. So the edge coefficients are calculated at specific points on the view screen. The diagram below shows where each term is located. In general, Y terms are calculated to at least 1/4 pixel resolution. XM and XH are calculated where the H and M edges intersect the previous scan line. Oh, because these are pixels. Okay. XL is calculated where the L edge intersects the next subpixel at or below the midvertex. So these DX things, DXH dy, DXL dy, those are DXM dy, those are the three negative slopes, right? The M is the major edge, the L and the H are the two minor edges, and then there are 6 coordinates. Which are basically in this these are sub-pixel accurate, which is why they kind of work the way that they are. H is the major edge, really? Okay. Seems like a dumb thing for terminology, but I believe you. Oh yeah, they are, aren't they? H is major edge, M is middle edge, L is low edge. Thanks, boys. It's not confusing at all. Alright, so we're supposed to start from the top of the scan line, which holds YH. Alright. So YH is right here. This is the scan line, I guess. In the examples above, it is YH minus 2, right? Okay, that makes sense. And the way that you would find this is basically just to clip it to the previous multiple of 4. Calculated to at least subpixel resolution. Okay, so you clip that to the lowest, the next multiple of 4. Let's just write this out in code comments, shall we? So we don't forget what we're doing. That was weird. I had like some sort of brain fog moment where I thought that J was K and K was J. All right, so clip YH to previous multiple of 4. Wait, what happened to the... Oh, I closed it somehow. All right. We have intersection point of major edge with the scan line, XH, YH minus 2. Intersection point of first minor edge with the scan line is HM, YH minus 2. Okay? Descend down by the edges using given edges inverse slopes. For YH minus 1, x coordinate for point on major edge is XH plus the XH dy. X coordinate for a point on minor edges. Yeah. Okay. This is where X, M, and XH are defined. Then walk down edges using slopes. Render nothing until xh minus xm is positive for left major triangle, or until it is negative for right major triangle. So render if xh minus xm is greater than 0, or xh minus xm is less than 0 if right major. These conditions mean that our edge points are not inside the triangle yet. Rendering is not started yet at YH. Rendering starts meaning pixel rasterization between calculated edge points. Continue until YM coordinate. At this point, we start to slide along the second minor edge. XL is used as the starting point on the minor edge, and blah, blah, blah. Continue rasterization as long as the edge points are inside the triangle. Okay. So continue until YM. Then deal with minor edge to do. Alright, so we're just going to render up to the minor edge and then stop. It looks like, since you can't fill it partially, it has to do with all of the coverage mode stuff. I think, how do we want to handle that for now? Well, I think that Crom's test probably defines a coverage mode. Right? So this is other modes, cycle type fill, fill color, blah, blah, blah. Alright, so let's look at the other modes, because I feel like that probably tells us. Other modes, 27. And then the other one that it could be is 25 or 32, I guess, but let's start here. Display pipeline, texture LOD, power texture sampled, chroma keying, blah, blah, blah. Hello, cat. Ah, cat. Okay, yes, hi, good boy. Okay. Yes, he's extremely fluffy. He's very cute. It's just kind of annoying. Although I guess that's a pet thing generally. Yeah, that's not what I wanted. Alright, well, here's what we're going to do. We're just going to assume that any pixel that has any color is going to get rendered. No, we're not going to do that. We're just going to only check at pixel boundaries, and if it's not the whole pixel, then it's not going to get rendered. That's what we're going to do for now, and then later we'll learn about the various modes. Okay, so clip YH to previous multiple of 4. Let YH whole pixel equal. Do 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 do. I mean, I guess I could just divide by 4, multiply by 4, and this would work, huh? What am I looking at here? Yeah, so it's just .yh. Is there a fraction for YH? I don't think that there is. Nope. Cat, you're like right in the way. I can't read the text on the screen. Why must you be this way? Okay, so that's fine because it's already rounded. What if we use 202 just to make sure that this actually works the way that I expect it to? Oh, well, okay, it was 200, so I guess it's fine, even though that didn't actually test what I thought it was going to test. All right, so that's easy enough. Now we want to walk down the edges using the slopes. So we're at YH whole XH, right? Oh, cat. Ah, other cat. No, why? Oh, God. He stepped on the F keys and everything went crazy. This is the other cat, if you haven't seen him before. He's also very sweet and also sometimes kind of irritating. I might have to actually lock them out because they're getting annoying. They've got an hour left until dinner time, but this is around when they start sniffing for it, so that's what's going on. Okay. Alright, so that's where we are. But they need to make sure you're available to give them dinner on time. Yeah, they sure do need that. Alright, come on, guys. I'll be right back. I'm going to kick them out and lock the door, or close the door. Come on, guys. Yeah, attaboy. You kitty. You too, come on. There you go. Boys, see you again soon. Okay. Kicked out the kitties. Sorry, boys. I'll be out in an hour to feed you. Am I doing on time? Oh, fine. Okay. I have eaten so much food today, and I'm still hungry. Okay, so let H position equal YH whole pixel coefficients dot XH. Let M position equal YH whole pixel coefficients dot XM. Except it's not actually going to work that way because there's fractional components to the X values. So we probably are going to want to deal with that. Let's do it this way, though. Am I planning on doing software rendering? I'm going to start with software rendering. So the plan here, I guess I probably should put this into display or something. The plan is I'm going to write like the dumbest, simplest software renderer ever. And then I'm going to like do performance measurements and say, okay, how fast is this? And based on that, the next step will either be to SIMD and multi-thread the software renderer, or to move over to hardware rendering. And it's basically just going to depend on how close I think software rendering is to acceptable performance. I would rather stick with software rendering for a number of reasons. I think it's more portable. I think it's easier to make it more accurate. But yeah, I think it's more fun. But I do think that there's likely to be places where hardware acceleration is going to matter. And then the question then will be, how do we do that? The answer is probably going to be more on the compute shader side than it is on like the regular graphics side, because the blending modes and stuff, my understanding is, are pretty weird, and it's like difficult to get OpenGL, for example, to just do that in hardware mode. So we'll probably be doing a lot of like compute shader stuff, which is something I think is cool anyway, which is honestly the whole point of this, is that I want to do things that I think are cool. So that's the plan. What was I doing? Oh, yes. Self u32 self dot xh. Oh yeah, this is going to be xh. Left shift 16 or self dot xh frac as u32 as u32. So we get the whole thing. This can just go away for now. Right, so xh. And then we'll do the same thing here. xm. And then you know what? Maybe as long as I'm in here, I'll just implement YH and then everything won't need to be. Hub anymore. Okay, so that ought to work. H pause and M pause, and then we want to walk down the edges until we hit YM. So we're going to do let scan line equal YH whole pixel. These are all going to be mutable probably, but certainly scan line will be. So while scan line is less than xm, or ym rather, scan line plus equal 1, it's going to be at the end, checking scan line, and then we just got to implement the ym, which is equally easy. Right, no fractions for that. Alright, let's see what we get when we run that. Hey, nothing works, because I forgot to put fun on them, which is fair. I haven't written enough Rust yet that I don't make dumb syntax mistakes all the time. Even though, like, if you ask me, I would know better. Oh, right, the fields are all pub because I don't have a constructor. Alright, fair. Don't make everything pub. Write a constructor. Can everybody read this text okay, by the way? I tried to zoom in so that it was sufficiently legible, but it's hard to tell from this side of the stream whether I need to be more careful. You can read it. Okay, good. I'm on a decently small laptop screen. That's good. That sounds like it's acceptable then. Okay, so it turns out that waiting and doing the minor edge stuff later won't work, because if we look at the picture of the example triangle that we're trying to render, it's immediately minor edge, right? So the one that we're looking at is this red one. I guess X or YM is immediately a thing, so you can't get away with ignoring that. In non-minor edge mode. And then the next thing is move down until YM coordinate. Start from top of scan line. Descend down the edges using given edges inverse slopes until distance between points on edges is positive for left major triangle case, whereas negative in case for right major triangle. Take the point on the major as the first vertex. Calculate color depth and texture coordinates for that point using GPDE. Blah, 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 blah. If the distance between the points on the major and minor edges is not 0, take the point on the minor edge as the second vertex. Move down to ym, move down to yl. The only difference being that you use l instead of m at that point. Okay, so that makes sense. Is this algorithm specific to N64 for some reason, or is it just general triangle filling? It's just general triangle filling, except for like the specific representation is N64 specific to some extent. But I mean, the basic principle of like, hey, you got some edge functions, that's all generic. But unfortunately, I have not done enough graphics to really be able to just look at that and bang out an algorithm. So there's going to be a lot of referencing for at least the beginning of this. Honestly, I meant to be a little more prepared for this stream in terms of like knowing kind of what I'm doing, but this has been a very busy week. Life is very busy at the moment, and so I didn't really have the time to do that, but that's okay. Okay, so there we go. We got some scan lines from 200 down to 400. That doesn't seem right. I know that the X or the YL. Oh, this seems backwards, doesn't it? YL big, YH small. Maybe it's reversed. Or maybe I'm parsing it wrong. Nope. YL 100, YM 50, YH 50. Oh no, that does make sense actually. YL should be bigger. It's 400 and 200. Oh, it's because they're subpixels. They should be plus equal. They should be ym divided by 4. Okay, that should be better. Oh, also, yeah, so we're just going to want to divide by 4 there as well. This is obviously the wrong way to do this because the subpixel stuff does matter, but we're not going to worry about that today. Okay, 50 to 100, that's what we expect. Is an edge coefficient a single edge? No, it's 3. Right? It's all of these values, xm, xh, yh, ym, yl, and the slopes, and xl, obviously. Alright, so the next thing is to actually start drawing some stuff. So we want to update our x position. Aw, poor kitties are clawing at my door. They want in. Sorry, boys, you were too annoying. hx plus equal, it's going to be just times the slope, right? Or plus the slope, rather. Coefficients dot, what's it called? dx h dy, I guess. dx h dy. G. Okay. Between and that won't matter because it never gets run. Oh, it's MX, obviously. Okay, that won't matter because it never runs. Then the transition here is basically just that you switch. Instead of using M, you start using L as the minor edge, and we use this junk. So, okay. Let mute LX equal coefficients cell. Doodle-doo. Just crank all these out. S, XM, XL, G. S, M, L, G. It's all build, so that's good. Between and HX, MX. Alright, and then we keep advancing this way. Then we advance this. IDLs. I misspelled coefficients because I can't spell. There we go. Hey, we exploded. Awesome. Attempt to add with overflow. Between 16 billion and 16 billion. Cool. Guessing the sum of the slopes are negative? Yep, this one. This one is negative. I wonder if I don't know what I wonder if. These folks are obviously I-32s, so let's do that. This is not going to work because I'm adding a U32 and an I32. What if we just made everybody an I32? Why the hell not? I feel like this is probably not right. This is one of those situations which I feel you get into a lot in CS stuff, especially graphics stuff. Although also, like, anytime you try to interface with the external world in any way, where if you had something that you could see, then it would be easier to debug, but when you have nothing, it's challenging. Oh, obviously this obviously needs to be L. Oop. Okay, this makes sense to me. Those look like reasonable pixel values, actually. So now let's just draw everything that color. So let HS pix equal HX16, MX pix MX16, for X in HX.mx, FB, it's gonna be scan line times 320, which is the X width, plus X, 0xFF. And then we got to do it for all these other colors also. +1, +2, +3. These are going to be 0, 0s. And then we're going to do exactly the same thing down here, except that we'll make it an L. And we'll see what we get. We get very bad problems. Oh yeah, okay, so this is all just slice indexing, right? So let index equal scanline as usize times 320 plus x as usize. And then we'll go in here and we'll use index, index +2, x +3, and then we're just gonna replace this junk as well. See what we get. Oh, I didn't use hx pix, so that's why it exploded. Pix, 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 pix. Go baby, go baby, go baby, go baby. Hey, we sort of got a triangle. We didn't do it right, but we sort of got something. Well, I think I basically know what that is coming from. Times 4. Because each pixel is 4 bytes. Nope, that didn't improve the situation at all. I feel like it should have. So let's take a look here. Yep. Oh, well, this is obviously wrong. 240. This is also wrong. 240. I should probably be printing index just to see. Index. Pixel. X, Y. Index. Index divided by 4. X is X. Scan line. Oh, well, that's not going to work because we don't get that over here. So let's just... Oh, well, duh, dummy. I forgot to I am duplicating stuff, and that's why I'm having problems. I should extract that. Hey, a red triangle. Awesome. That's absolutely success. You know what I should do is I should fill with white so that we can actually see where the box is. See if it looks reasonable. And I should also scale the frame buffer so that it's bigger and more viewable, especially on stream. But hey, look at that. Total progress. That's awesome. I'm super proud of myself, even though I absolutely have no right to be. Cool. Times it. Right, so next thing to do is to start taking in these edges from the actual display list. So let's do that. Oh, actually, no, the first thing to do is to extract out this duplicate crap because that was causing me problems. So draw between pixels. It's gonna take FB, which is MU8. It's going to take X, which is going to be usize. It's going to take Y, which is going to be usize. And it's going to take color, which is going to be U84. And then we're just going to go ahead and extract this junk. Right here. We can get rid of the print, because who cares? Scan line is Y. And then this is going to be color 0, color I, or color 1. You know what, actually, for I in 0.4, index plus I, and then color I. I know, because this is going to be X start, X stop, scan line we can keep, I guess, actually. Let mu Y equal scan line, or actually, I guess we don't need to do that because it doesn't change. Let mu X equal X start. For X in, doesn't need to be mutable. X start dot dot X stop. Do this. Index scan line. And then we'll do that. Okay. And then we're going to go ahead and get rid of this. Fill between pixels. HX pix, MX pix, scan line. FF 00 00 FF. Alright, so hopefully that'll just do the same thing, but it didn't because I changed the name. Wait, no, that's not why. Takes 5 parameters, but 4 parameters were supplied because I didn't pass the frame buffer. Turns out when you're trying to draw to a frame buffer, it's important to be able to draw to the frame buffer. Expected use size, sure. Doo-doo-doo. Expected colon, yeah, well, that's fair. Gotta give things types. Ah, yes, a similar variable, blah, blah, blah. This needs to be an L. Okay, now we're back to where we were 5 minutes ago. Boom. Sweetness, okay. So now we're going to get these here pixels from, or these here edge coefficients from the actual RDP list source. So we're going to just crack this open real quick again. Pop this in at the top. And then the rest of this is basically, we still want all of this, I think. I don't know why I'm doing this. Doesn't seem necessary. Let's get rid of that. Yep, that should all be fine. And then in here is where we're going to actually do this thing. So, oop. instead of this, we're going to do match, or well, I guess we have to do it this way. Match command, magic RDP command, fill triangle coefficients. It's going to give you draw, fill, try. Let's emute FB bytes, coefficients. And then anything else is just going to do nothing. Use of undeclared type or module file system. Sure. Yeah, I don't think we need this. Oh, it doesn't have read command because I'm not using it. Following trait is implemented but not in scope. Yep. Use magic. What's it called? Read RDP commands. Go. Nope. Yep, 225. I should probably have just imported star from magic instead of doing this everywhere. Don't have try into. That's not how that works. That is. Borrowed value does not live long enough. Requires that value is borrowed for static. Okay, that's fair. Let's just do that every time, huh? Oh, and then I should get rid of this, obviously, because I'm double drawing. Is that gonna work? Yep. Jeez, cat, cool your jets. Assertion failed. Command bytes. Length. Huh. That's weird. Okay, nothing happened. File is num bytes in size. Oh, I do actually need that resize thing. That's why. Dumb. Oh, I'll just modify this for no reason. All right, there we go. Okay. We don't seem to be entering that branch of the match. Nope. Are we entering this part? Also no. And option. Go. Show me what's going wrong here. Huh, so we're only getting invalid inputs? That's weird. Seems like there should be other problems. Alright, well, let's just make sure we know how big the file is. Maybe it's not being found. Bytes. No, it thinks it's 464 bytes long. Let's just make sure the test still runs, huh? Yep. Right, so we're still getting commands here. So how come it's not working here? Oh, whoops. I feel like maybe I need to I don't know, like seek it backwards or something. Let's put a print in here. Let's see what we're getting. Or if we're even calling it. Yeah, we are. Oh. Yeah, I mean, okay, sure. That makes perfect sense. Which I guess it should. I knew I was going to be doing something silly. Alright, so the thing that we need actually is that we're not looping through commands anymore like we are here. Even though that's not really a good way to do it. Let's just do it that way anyway. Oops, too far on the deleting. This is the other downside, by the way, of the JK option as how to as your escape command in Vim, because if you are visual mode selecting downward, you can't always tell exactly how far down you're going to be going. Yeah. Right, and I had that imported, and then I was like, I don't need this. And I was wrong. Okay, go. Unused variable command option. Oh, hey, look, we got all the triangles. They're all red, because we don't have colors implemented yet, but we've got all the triangles. That's awesome. I'm proud of myself. I drew some triangles. It feels good. I should delete some of these prints, though, because they're a lot. Now that we know it works. To first order, anyway. Why do you think command option is not used? Oh, I guess I could put it in here. I'm proud of you. Thanks, Nick. I feel good. Na 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 na. Are you gonna stop telling me I have warnings? Nope. Why do you think it's unused? It's totally used. Oh, I bet there's another one. Yep. That's why. Okay, better. Alright, so now we gotta implement some colors, I guess. So, let's add parsing for the set fill color command, which I already did. Look at me. Good job, pass me. Now, what we want to do is let color equal Fs. Also, it needs to be mutable. Mutable color, fill color, colors. Color is equal to, I'll just make these colors.color1. Yes, it does complain about that, but I'm not using Clippy currently, so it can bite me. I think it's 2 BE bytes. Is that what I want? I've got this open right here. From and, yeah, 2 BE bytes. It's set fill color, not fill color. Totally fair. How far gone must a man be to forsake Clippy? I mean, it needs to work first. Oh. Well, okay, I messed that up, obviously. This needs to exist outside the loop. How many roads must a man walk down? Alright, well, that's wrong. Interesting. What am I doing wrong? Let's take a look at the assembly, shall we? Whoa, getting there with the test ROM. Yep. Feeling good. In the neighborhood. Maybe it needs to be LE bytes. That would make sense to me. You need to get good. Okay, well, that's not the problem. Alright. Let's just, every time we print. Actually, you know what? Let's not do this. Let's set this to FF0000FF and make sure that it works. Okay, it does, because you get these all these tier triangles. Oh shit! Thank you for the 2 cents, Pixel. Now you're number 1. You defeated Diana yet again. Yeah, I guess I'll just set this to 0. And then if we do this, just do setting color to color 1. Ha! We've got a full-on bid war going on for my love and affection. Well, those all basically look right. So let's go back to doing this and just try all the versions of colors that exist. Okay, so the triangle is that pukey yellow color, and then we try 00FF, 00FF. What? That doesn't make sense. It's not changing at all. So first of all, that needs to be big endian. Why is only half of it green? I know why only half of it is green, because I'm a dum-dum. I didn't change this part. Now it'll be green. There we go. We were only drawing half of the triangle with colors enabled. Alright, let's try this again. See if that helps. Yo, progress. Obviously not 100% correct. Oh, it is 100% correct. You just can't tell because I didn't draw the yellow rectangle. Woohoo! All right, I'm proud of me. Again, I continue to be proud of me. All right, next up, fill rectangle, obviously, because that will enable us to draw that ugly piss yellow color on the background, and then we'll match Cron exactly. Probably. What, Pixel? You don't agree with my assessment? It's an extremely ugly color. These are 10.2s. I guess those are in subpixel coordinates for some reason. Obstruct rectangle. It's a 10.2, so that's a U16. X, I don't know, YL, U16 is going to be XH and YH. XH, U16, of YH, U16. And then what we're going to do is return OK, RDP command, fill rectangle. Rectangle no longer looks like a word. That didn't take long. Alright, so you're at index 44. Value, right shift 44, and 0x, it's what, 12? So 0FFF. And the as U16 can go in either location. The only true issue with programming. What is? Y, H, Y, H. 32, 12, 0. It's going to yell at me for doing a useless shift, probably. XL, YL, XH, YH. Having words not look like words. Yes, that does certainly happen. What's your problem here, buddy? Oh, unclose delimiter on that one. Okay, now we gotta actually implement the rendering, but we appear to parse it. Well, actually, we don't know that. Let's do this. Compare first. All right, so fill rectangle. And what we're expecting is X low, 319, 239. That looks right. Right enough anyway. Alright, so now let's actually render with draw, fill, rect, FB, MU8, rectangle, magic, rectangle, color E32, let XH pix equal rectangle XH, right shift 2, SXYG, oops, SHLG for X in, or no, let's start with Y, for Y in YL pix, YH pix. Is that right? No, it's the other way around. I guess because of how the coordinate system works. Ending all your sentences with semicolons. Yeah, for real. XL pix. Alright, and then basically just gonna do fill between pixels, FB, X, as you size. Oh no, actually we don't want to do that. The loop is in the thing. So XH pix as you size, XL pix as you size, Y as you size, color.2b bytes. I think that's pretty much it. And then I have to add it to the parsey bit. RDP command, fill rectangle, rectangle. Draw, fill, rect. Mute, FB bytes, rectangle, color. Alright, kiss yellow background, here we come. Nope. Can't spell rectangle, doesn't look like a word. That was just a typo, actually. Boom! Yeah! Perfect. Absolutely pixel perfect perfection. Probably. I mean, it looks like the thing. So that's good. Awesome. Nice job, me. Okay. I'm going to go feed the cat. This seems like a good point to take a break and feed the cat. What's the next test ROM? Alright, let's check that out first. Have an export screen button. Yeah, I was thinking about that. I don't know enough about ping. Is ping lossy as a format? Because I can probably just dump it as a ping. And then compare. But I don't know if there are like settings and junk. Ping is lossless but compressed. So I should be able to just open this up and save it as a bitmap. Alright, what is the next test ROM? Good question. I'm not actually sure. I guess the next thing would be the next level of triangles. Either that or getting the like partial coverage modes correct. But I feel like the new kind of triangle is A, more interesting, and B, requires less pre-reading that I didn't do. So that'll probably be what we'll do. So we've got shade triangle will be the next thing. But for now, I will feed the cats, and I will be back momentarily. Okay, I'm back. I could do the export screen button thing, or I could work on shaded triangles. Which do you guys think is more interesting? Probably wouldn't be that hard to do. Oh, that wasn't what I meant. What were the choices? I could either like export it as an image and compare it against Chrom's ping to make sure that it's absolutely 100% correct, or I could get started on the shaded triangles. Shaded triangles. Yeah, I agree with you. All right, let's do it then. So, in case you weren't here for this process last time, the way that this works is that I have myself a custom build of N64, which will dump out the RDP lists for me when I run it. What is it called? Wait, what? Cycle 1 shaded triangle? That's not what I wanted. I clicked the wrong thing. Is there no non-cycle 1 shaded triangle? And if so, what is the difference? Because I should do cycle 1 fill triangle first. Huh. Alright, what's the difference? If we look, this is the fill triangle one. That is not cycle 1. So the difference here, we still have cycle type fill, but we set sample type alpha dither select no dither. I think we can probably get away with ignoring that. And then there's this combine mode, which is probably not as easy to get away with ignoring. And then actually, you know what? Are all those triangles right major? That's interesting. I wonder why this test doesn't test left major triangles. I mean, I guess it could if you commented this out, or uncommented that out, but odd. Oh well. Alright, let's just try this and see what happens if we don't worry about what the hell this means. Alright, so step 1, parse the shade triangle. Well, first one is get the shade triangle command, so let's just do that, because I was in the middle of doing so. Alright, cycle 1, shade triangle, go. So this is what it's going to look like. Pretty standard OpenGL demo RGB triangles. And we logged the words correctly, so we're going to go ahead and copy that to shade list. Lerp, yep. Create a new example for this one, just to keep things kind of... Actually, I should move the drawing bits actually into the library instead of the example area. So we'll do that. Put it on here. Paste that boy. Pub these. And then fix that. Go to the draw fill. Magic. then we'll just make sure that that works. Nope. Is not. Oh, it's in this one, that's why. Alright, so, yep, that works. Good deal. And then we'll copy that over again because I screwed it up. Examples, shade triangle, right? And then instead of the RDP list, we'll do shade list. I should probably put that in some sort of resources folder. All right, we have a yellow rectangle because it doesn't contain any fill triangle commands. So let's go and fix that, shall we? So shade triangle does have edge coefficients because it is a triangle, but then it also has shade coefficients. So if we look at shade coefficients, wow, that's a bunch of stuff. I guess it's not that surprising. Shade coefficients. And let's make sure we drive debug. All right, we got red, which is apparently 16 bits, red, green, blue, alpha. Green, blue, alpha. DR, DX. These are all also going to be 16s. Green, blue, alpha. Red fraction. Okay. The DDX fractions. These probably aren't all X, actually. Are they? No, they are. We're just going to get DE and DY later. Okay. Now we got this. DX, DE. And then DE, DY. And then the fractional version is just take all of these and add. Whoop, too much. Frac. Okay, that's easy enough. Just gotta actually go ahead and do it now. And then we're probably also gonna have to implement the give me the whole thing stuff in a minute as well. That's no big deal. I should fraction some of this out just a bit. Like, especially I should make a read edge coefficients thing that handles that whole mess instead of duplicating it. Shade triangle, 0C. So you do this, get rid of this. Get rid of this. And then we're gonna just do let red equal, oh well, we need to read more data. 48, I think. Yep. Blue, green, alpha, 32, 16, 0. TRDX, BGA, oh no, GBA. I don't know why I couldn't do that in my head for a minute there, but it's fixed now. Let's do this again. Fractions, fractions, fractions. Probably there's a way I could arrange this that would be significantly less repetition, but oh well. At least it'll be clear. Okay. TRDX to GDX. So this is the same except SDXDE. And then again, SDDY. And all this junk, but with fractions. And then I just have to actually make the thing to let shade coefficients red, green, blue, alpha, DRDX, DGDX, DBDX, DADX, these but with fractions. Jeez. These but with fractions. These but with e's. These but with y's. These but with fractions. Frac. Okay, there we go. Oh, I didn't put a semicolon, and then I need to return okay. Shade triangle. Edge coefficients, shade coefficients. Alright, does that work? I misspelled coefficients. This needs an RDP command on the front of it because that's not automatically imported into scope. Okay, it builds. It still doesn't draw anything, but that's okay. Step 1, we're just going to draw it with the fill command. I should close that so I don't screw it up. Right, so we're just going to take this exact same thing, and we're going to do it with the shade triangle instead of a fill triangle. Let's see what we get out of that. Apparently not much. That's surprising. You know what I should do, actually, is I should run the MooPen thing, the example list. Oh, it's not going to work because it's pointed at the wrong thing. Well, we can change it for now. Okay, so we definitely are hitting them. I'm guessing we're probably not setting the fill color to anything but the horrible rectangle puke color. Yep, because it's not filled, so that doesn't work, which is fine. Actually, what if I just don't draw the rectangle real quick, and we should get puke yellow triangles, hopefully. We get a puke yellow triangle. I feel like we should get more than that. Oh well, I guess. Alrighty then. We need to do a draw shade try implementation, which is going to be try. That's a different kind of try. All right. This should basically work the same, except that we should also have linear interpolation of color. So it actually won't take color in. Shade coefficients. Yeah, I just can't look at that word anymore. It's terrible. Okay, so we still want to do this, but we also need to interpolate the shade coefficients, which are, you know, the color at these various places. We have the DRDX. I'm not sure what DRDE is about, so changing red per change in X coordinate. Change in red along the edge. And then change in red per change in Y coordinate. What is the edge in this context, I wonder? Is it whatever the minor edge is, maybe? Along the edge. I mean, I guess that would kind of make sense. No helpful drawings for shade coordinates, huh? Nope. Alright, well, we'll just assume that that's what's up. So we'll keep all this the same, right? Which probably means it should be extracted. Edge coefficients. This is really kind of like a vertex shader thing. Alright. Let mute red. I feel like it needs to be a U8 because that's what it's eventually going to get drawn as, but green, blue, alpha, and this obviously needs to start with shade coefficients dot red, green, blue, alpha. Okay, we're gonna need to implement that. I don't know why I copied all of this. I only really needed one example. It's gonna be this guy here. I'm gonna let these be U30s, or yeah, U32s. Oh no, I can't because it might be, yeah, okay, that's fine. Self dot red, self dot red fraction, and we'll just do this again. S red blue or green. S red blue. S red alpha. I don't know why each color component is a U16, but yeah, it is. It seems a bit odd, doesn't it? It's like 32 bits of precision for each color. But it's not like we're going to draw a 128-bit color, so I don't really understand. I guess smoke them if you got them, right? All right, so we got that. So, right, we're chewing down this way. We don't get to use fill between pixels this time. So let's copy this out of fill between pixels. And we're going to have hx pix, mx pix. Get rid of that. Red, left shift, red as U8, left shift 24, plus green as U8, left shift 16, plus blue as U8, left shift 8, plus alpha as U8. That's not going to work. Yeah. Always need more parentheses. I guess I don't need those. Okay, so then we want to get color. Well, color is going to change across the scan line. Alright, so yeah, we probably actually want to call this every time, right? Just do let color equal that. And then as we are advancing across this whole thing, all right, so this inner loop is dx, right? And we want d rdx, d gdx, etc. So we'll go ahead and make those. S red drdx. Oops. Oh, that's supposed to be an underscore. GDX, what? Oh, S green dgdx. Blue dd dx. Alpha da dx. Okay. So we're going to want to do red plus equal dr dx. S red green. S red blue. Actually, I don't need to do that because it's not actually contained in the thing. This becomes A, B, G. All right. Right, because I didn't change this yet. Let's just get rid of this. Oh, I don't actually return this, do I? Oops. Yeah. Data Z32. Cannot index into a value of type, which is why we're going to do 2B bytes. Well, that's something, ain't it? I'm surprised it lets you implicit return without a type specified. It didn't. I had a semicolon at the end. Well, I mean, I guess that is implicit returning, but you know what I mean. Okay, let's, all right, so that was the X across. Now we're gonna want to do the Y across. Dx, dy. Didn't actually implement that. Totally fair. Literally all I have to do is paste it, and then S dx dy g. Okay, still black, not a great sign. I think I'm converting the color wrong, which makes complete sense to me. Boobadoo, boobadoo, boobadoo. Okay, so how does the DE get factored in? That's the real question that I have. Change in red along the edge. What edge? So that's X, that's Y. What does along the edge mean? Oh, okay, so start from the top of scan line, descend down by the edges using given edges inverse slopes until distance between points on edges is positive or negative. Take point on the major edge as the first vertex. Calculate color depth and texture coordinates for that point using DPDE. Take point on the minor edge as the second vertex. Calculate color depth and texture coordinates from that point using DPDX. Still don't really understand where DE comes into things. Well, As mentioned before, the amount of change goes not given per vertex. All the information is given for the major edge. Initial values are calculated for the point where the major edge intersects the previous scan line. Besides the initial value, each parameter P provided with dpde and dpdx. dpde is used to change parameter along the edge. So value of every parameter on the major edge should be calculated for each sub-scan line. But then what's dpdy for? It is enough to have an initial value parameter P with dpde and dpdx calculate P for each pixel inside the triangle. But there is a dy, so what? Maybe that's only used for the other type of rendering, like when it's in this zone. I guess that would make sense. Kind of. Not really. But it sort of makes sense. So yeah, I don't get it. Well, I mean, when all else fails, how do shaded triangles work? N64. Didn't really think I was going to get this dropped in my lap. Oh, maybe the manual has something useful. Probably not. It's probably operating at a higher level, huh? Alright, well. Let's just try some stuff, I guess. First of all, let color equal ff0000ff. To be bytes. Yeah, you're probably gonna make me U32 it. How come I'm only getting half a triangle? Well, I know why I'm getting half of it, but why am I only getting one? Paste this over here. It's a bad way to do this. Gonna do it anyway. Okay, so again, only getting one, which is a bit odd, given that I'm hard coding the texture color. So what the heck, man? Oh, I only have samples, shade triangle. Okay, so it does get called a bunch of times. Yeah, these are all different. So what the heck is going on, huh? Oh, I probably should take out that explicit panic. Otherwise, it's not going to do what I want it to do. Draw it without the background. That's so weird. How come I'm only getting the one? Even though there's a bunch more. Am I like clearing the frame buffer somehow? Don't get it. Here's what I'm going to try now. This is a dumb reason. It's a dumb plan, but I'm going to do it anyway. Draw, fill, try. FB, edge coefficients. FF0000FF. I don't understand. It's not a good thing. Am I getting... Oh, maybe some of them are right or left major triangles. Or are supposed to be. No, it doesn't really look like it. These all say right major. But maybe they're supposed to be left major? Let's check. This is the shade triangle one. Oh yeah, those are left major. Or at least that one is. Okay, so that's probably why then. I'm not actually handling that any differently. And also, I'm doing it wrong. Seems. So, cool. Okay, let's put the panic back in. Just move on. Alright, so we have value 0C00. Oh, well, yeah, okay, that makes sense. I just goofed up completely. It's not 08, it's 0080. Like that. Okay, so now these are not right major except for this one, which is why that's the one that gets drawn so I can see it. So I need to add the right majorness of it. And I think all you actually need to do for right major is just reverse the order for the comparison. So if we go in here to draw, fill, try, did I even actually handle that case? I may not have handled that case at all. Probably because I'm going by whole triangles right now. So what you actually want is to reverse this comparison right here. There's definitely a better way to do it than what I'm about to do. Coefficients dot right major. Then do it this way. Else, do it the other way. Definitely better ways to do this. And I'm pretty sure it's just the opposite, right? Or maybe just greater than. Oh, I left the panic in. Get rid of that. Nope, didn't help. Until xh minus xn is positive. Huh. I think, so I'm basically just ignoring it. So maybe all I need to do is reverse whether M or H comes first here. That would maybe make some sense. Are we checking every pixel of the screen for being inside the triangle currently? No. No, we're not. We're only checking in the, we're not even checking only in the triangle bounding box. We're starting at the top and walking down, and then just going left and right based on the edge functions. Hooray, we've displayed all the triangles. So great, that's progress. Now let's go back to the real thing. Let's get rid of this. Oops. Ooh, fancy. I mean, kind of. I'm literally just following the blog post, but it makes sense to me why it would work that way. I think that there are even fancier ways to do it that would be better, but I need to fix how I am doing the major thing so that I can copy it down there without it being a huge pain in the butt. Alright, so let's get rid of that, and all of this. Yep, and then we're gonna do let left equal if coefficients right major hx pix else mx pix right not left right. Oop. L L, copy, paste. Unexpected close delimiter, A. Oh, okay, yeah, fair. Okay. Yep, and then we're just gonna go ahead and do exactly the same thing down here. L, left, right. Okay, so now we should get all of the triangles in black, except that we don't because it's not coefficients, it's edge coefficients. Okay, now we should get all the triangles in black. Yep, okay, so we get all the triangles in black, which continues to tell me that the problem is how we're converting to RGBA. So how are we doing that exactly? Converting go. Okay, that's obviously way too much. How come the alpha is 0? That doesn't seem good. No wonder nothing works. Actually, I'm surprised we got even as alpha as this. I probably need to right shift all of these people by 16 first, at least, because they are going to be offset. And then my map from U16 to U8 probably should be divided by 65535 times 256, or something similar, instead of what I'm doing right now, which is just dropping the bottom 4 bits. Or even just right shift by 1, right? So, okay. So let's do that then. Alright, so we're going to take color, right shift 16. Actually, right shift 7. No, that doesn't work. As U16, and then how do you map a U16 to a U8? I feel like this is something that Vue blog post from a couple days ago talked about, except it was going the other direction. Whoa, hello, Timbo. I don't know how to say thank you for stopping by. I'm working on an N64 emulator in the programming language Rust. I hope that's of some interest to you. Currently, we are this far. We can draw some triangles. They're all black. We'll get there. What brings you by? How's everybody doing? Welcome aboard. What am I supposed to do here exactly? I mean, I guess I could just shift it by 24. That should probably work. Not particularly well, but it'll work. You were streaming for 14 hours and had to end, and here we are. Wow, that's a lot of hours. Holy cow. I will never do that. What was he working on? Or what was he doing? Sorry, I'm not familiar with you. I make my own frameworks in C++, but haven't done any emulators. Nice work. Thank you. Yeah, this is pretty new for me too. I've done one other thing, which is I tried to write an NES emulator in 2 weeks or less. You can find the videos on my YouTube channel. If you type !YouTube, that'll show you the playlist from that challenge. I did not quite complete it. I ended up with something I'm calling Cursed Donkey Kong. But it was a fun experience, and I care a lot more about the N64 than I did about the NES, so I decided once I was done to move on to that, and that's what we're doing now. I don't know any programming, I just like looking at the colors. Well, hopefully I'll get some colors working in a minute for you to look at. Today I was doing Discord and Twitch overlay bots, then a bit of art practice. Cool. No method names. Oh, okay, fine. That's not really how that's supposed to go, is it? Alright. Just moving bits around, as usual. Okay. Doodly-doo. Well, thank you so much for the raid. I really appreciate it. I hope that folks find this interesting. Feel free to, you know, all the usual stuff. Like, comment, subscribe, smash that like button, etc., etc. But seriously, the greatest gift of all is just that people show up and watch and find things to be even remotely interesting. Makes me very happy. Okay, so now we seem to be getting some non-black colors, which is good. Our alpha still seems to basically be wrong. Let's just hard set alpha to FF for a minute and see what we get. Oh, I'm adding these. That's probably also wrong. I don't know what I was thinking there. Is there any questions that anybody has or information that you would like me to give you? How long until we can shine get? Wrong system. Okay, so all the alphas are 0, which seems incorrect. So let's just set it to F. Wrong console. We can get regular stuff. Okay, these are some colors. They're wrong, but they're something. It's progress. Let's see. Let me just show you what it's supposed to look like. It's supposed to look like this. Your sort of basic OpenGL style shaded triangles. It doesn't obviously look like that at all. What's the blue in the corner of the one triangle? Excellent question. I don't know. I think my fundamental problem here is I don't understand the color format that the N64 is using because it's like 15.16 fixed point color for every color component, which is way too much precision, and I don't know how to squish it down into something I can actually render. Okay, let's see here. Don't have a ton of time left. Let's see what we can do. I'm also not really sure. So there's 3 components here. There's the dx, dy, and de slopes, and I haven't figured out what the de slope is supposed to be yet either. So Doesn't seem like it should really be that difficult, but well, at least we've got something now. But it seems like nothing is changing at the rate that it's supposed to be changing. Right? Because this is all red. And if we look at the example, that just means that nothing changes across the thing. So let's just render exactly one line and then bail. And we can see what we thought we were drawing at every step. Let's go right here. Drawing pixel at as X scanline color. Upper hex is not implemented for. Okay, sure. Let's do it this way. 2B bytes. 2. All right. So we're just going to draw one scan line of one triangle. Oh, that's probably. This needs to go away. Okay, the reason we're getting that is because none of them have a left major edge. So let's just take this down here. Okay. So this is our 1 pixel. How come our scan line is changing? Oh, because I'm not panicking. SM64 when? Not for a while, Pixel. Yes, so Pixel just nightbotted up the link to the Emulator Discord. That's where a lot of us are hanging out and talking about our various projects, including this one. So if that's of interest to you, please stop by. I don't think I'm adding components correctly. Either that, because there's no way red goes from 0 to F immediately. So let's take a look at that. So red, that seems about right. The RDX, that also seems about right. So let's print what the values are. Red is the RDX is shade coefficients drdx. Red is 0. That doesn't really seem right. I should be printing the, I should be, doing that so I can see the edge coefficients. Okay. Oh, I'm only printing the edge coefficients. That's not what I want. Okay. Red is 0. Just surprising. Wait, how is red 0? if it starts with red. The RDX is negative, so it gets less red as it moves away, which makes sense. And then I guess the red is wrapping around because that's not how addition works. That doesn't seem right. I should look at the actual command because I don't believe that that's supposed to have red there. Although I guess it could be at a different location than I'm thinking it is. 2550 though, that seems right. Are these coefficients inverted? Because alpha is 0 and all the alpha stuff is 0 forever. So maybe it's like backwards somehow? Or maybe I have to care about this in a way that I'm confused by. I should probably do that. Alright, set combine mode. Let's learn about that for a second. Set combine mode, 25. Okay, well that's not very helpful. The color combiner implements the equation on each color. RGB and alpha channels are separate mux selects. In addition, there are mux selects for cycle 0 and cycle 1. If it's configured for one cycle mode, set cycle 0 and cycle 1 mux selects the same value. Okay. So this is probably what I'm not doing then. A multiply. Yeah, this is definitely what I'm not doing. So because the color combiner equation, like you could end up with all sorts of bananas junk based on that relative to. So this is the 2 RGBA equation that I don't have. Time for me to jump off and sleep so I can wait for stream tomorrow, 6 a.m. to 9 a.m. every morning to every day. Wow. All right. That's awesome. If that's Pacific time, I'm sad to say I will never watch your stream because I always sleep later than that. Have fun at Waggle Turtles. Thank you, Tim. I really appreciate you stopping by and bringing everybody with you. It really means a lot. I hope you have a great night's sleep and a great stream tomorrow. Right, so this is definitely what I'm doing wrong. I gotta go and parse this out. I also stream most evenings, 6 p.m. to 11 p.m. times or Eastern time. Okay, that I can probably catch someday. Yeah, so this is the problem. I need a color combiner. How much time do I have left? Okay, I got time. So, step 1, let's parse that. Ish. Do-do-do-do-do-do-do-do-do-do. Set combine mode. Combine mode. Obstruct combine mode. Okay, so these are all like 3 or 4 bits each, huh? Cool. Cool. I'm gonna write myself a little like read field method just cause I don't really want to have to keep doing that over and over again. And then we're gonna return it as a U8. So make it a read field U8. Value, right shift by base as U8, and then I believe, if I remember correctly, that the trick here is to do and 1 left shift size minus 1. Right? Because if it's 0, then obviously you'll get 0. If it's 1, you'll get 1. If it's 2, 1 left shift 2 is 4 minus 1 is 3. Yeah, okay, that's right. Oh, that's neat. Yeah, it is. I wish I didn't always have to like do it in my head. That feels a little bit like a failure, but whatever. Oh, you know what I should have done next is I should have done the 16-bit per pixel rendering instead of shaded triangles, because then I could actually finish it today, but that's okay. Alright, let's just crank this out. Close this bad boy. Slam this over here. Alright. Sub A R0 U8 mul A R0 sub A0 mul A0 sub AR1 mul R1 sub BR0. Really? That seems... whatever. Sub BR1. These are in such goofy orders, it seems like. Sub A1 mul A1 add R0 sub BA0 add A0 add R1 sub BA1 add A1. I wonder if I duplicated any of those, because it kind of seems like maybe I did. Ultra 64 came up with terrible variable names. You are correct. Sub AR0 equal read field U8 value. Base is 52. 2, 3, 4, 5. So 4 bits, I guess. Mul R0 is going to be start from 47, 7, 8, 9, 1, or 0, 1. So that's 5 bits, right? And then sub A0, 4 bits, 4, 5, 6. That's 3 bits. Why are these all different sizes? Jeez. All right. Well, 44, 3 bits. Mul A0. 41, 3 bits, I think. Sub AR1 starts at 37 and is 4 bits. Mul R1 32 and is 2, 3, 4, 5, 6, 5 bits. Sub BR0. Boy, this must just be absolute poison to watch. 8, 9, 10, 1, that's 4 bits. $24, 4, 5, 6, 7, 4 bits. Sub AA1. 21, 22, 23, 3 bits. Mul A1. I'm just trying to figure out what the hell this command is doing. Yeah, it's very strange. It looks like basically what it does is that there's like a mux select. I don't understand what you're muxing though. And then based on that, you get the A, the B, the mul, I guess, is the C. And then I don't know where you get the D. I guess that's the adder input is the D. And then you can do this math and you get colors out of it. But I don't know what you're multiplexing. Hopefully all will become clear in time. Alright, so where was I? Oh, mul A1, 18, 19, 20, 3 bits. Add R0, starts at 15, 16, 17, 3 bits. Sub B A0, 12, 13, 14. Add A0 is 9. I don't think that the developers of games would have actually seen things at this level. At least I kind of hope not for their sake. Because you're right, this is kind of a mess of a command. 6, 7, 8. Sub B A 1. Start with 3, 4, 5. Add A 1. 0. Alright. And then we're just going to go ahead and take this thing, paste it right here, get rid of these bits, say OK. Well, first let's S colon dot star comma G. There we go. Probably didn't need the G. Definitely didn't need the G. Okay. Set combine mode to that combine mode. And then we'll be good. And now let's run this test again. What? Expected enum found null. 261. What? Did I break something? Did I paste way too much stuff somehow? It looks like I did. That's very weird. Yeah, you're right, it's not returning anything, but it already exists down below. I think I just pasted a bunch more stuff than I intended to somehow. Alright, looks like we parsed it. Let's compare it against the test source. It's so good to have the test source, I gotta say. That's fill triangle. Shade triangle, okay. Alright, here we are. 0, 0, 0, 0, 0, 6, 1, 0, F, 1, 0, 0, 0, 0, 4, 7, 7. Okay, that looks right. I don't know what the hell it does, but it looks right. Okay. Does this show up here and I just ignored it? No. Does it show up in the cycle 1 version and I didn't do that one? Yes, it does. 6 or 7. Or F 1, 0. What? I'm sure they thought they were being helpful with their set combined mode usage notes. Oh, hey, this might actually be helpful. One of the things you need to set in the RDP is the combined mode. You set the appropriate mode using the combined mode macro. To add color using primitive color, in other words, not using shading, you would instruct the RDP to conduct rendering using primitive color as follows. On the other hand, if you want to use a shading method, vertex color, or lighting, you would set the mode as follows to render based on shading. What? Okay, well that wasn't helpful either. Hi, cat. Oh gee, thanks. Set prim color, set env color. So I don't have one of those, right? Currently. Set prim color, set env color, set blend color, and then set combined mode. So maybe the multiplexer tells you which mode, which of those colors to use, right? But how are you supposed to know what they are? Does this have anything more useful? Not really. Okay, well that's not helpful, and that's also not helpful. So, Alright, I think I'm probably going to have to call it here because I have no idea what's going on, and y'all watching me randomly Google stuff or ask people on the Discord for help is not going to be super interesting for you. And also, frankly, it's 6 o'clock and I'm hungry, so I want to go get some food. I feel like this was a good stream. We made some real progress here. Let me just real quick run first triangle again so I can see a success on my way out the door. So at the start of today's stream, there was nothing. And at the middle of today's stream, there was this, which, as far as I can tell, and admittedly I have not dumped it to a lossless image format to compare, looks exactly like it's supposed to. Alright, so that and that. Looks pretty solid to me. So I'm happy with the progress that I made today, even if I didn't get shading completely figured out. I got some amount of rendering going. I feel like things are really moving along. So thank you all for coming. Thanks again to Tim for rating. I hope that I'll see some of you again sometime. You're welcome back anytime. I stream at least every weekend for 4 hours, or close in this case. And I may do some midweek streams if the mood sort of strikes me, which it probably will. This week was just bananas. So again, thank you so much for coming by. I really appreciate it. Please stop by again. Like, comment, subscribe, etc. And yeah, I hope to see you next week.